Hello teachers, good morning. Here we go. I have already discussed about the vector and scalar quantities and speed and velocity and what more? Distance and displacement. Now I have here the acceleration which I'll begin to discuss. Okay, so acceleration actually this is like how much the change in velocity in a given period of time. Okay? So the formula for acceleration usually is like acceleration is equal to velocity over the time, which is like the velocity is meter per second in seconds and time is in seconds. So the unit for acceleration is actually meters per square second. Now, sometimes we have, what's this? A certain object is traveling at a certain speed and then suddenly it stops or suddenly like it changes its velocity. We can have this one. Acceleration is equal to final velocity minus the initial velocity over time. Okay, so in this case, this is also the same as like meter per square seconds. Okay, there you go. Next one, I have here like the velocity versus time graph. Okay, now I'll begin to show you when is acceleration positive, when is acceleration zero, and when is acceleration negative. Okay, so as you can see here, before we're going to go in that part, I'll have here first some of the problems. This is just a basic problem. A truck is traveling at 6 meters per second in 12 seconds. So find its acceleration. Of course, this falls in the first formula, which is like the given velocity and the time. Okay, so acceleration here is equal to velocity over time, and that is like 6 meters per second over 12 seconds. This is the time. That is 1 over 2 is 0.5 meters per square second. Okay, so that's the acceleration of a truck that is traveling 6 meters per second in 12 seconds. Okay, there you go. Second one, the truck was traveling at 10 meters per second in 2 seconds before it stopped. What is the truck's acceleration? Okay, so in this case, we have here, what's this? Acceleration is equal to final velocity minus the initial velocity over time. And our final velocity is when the truck stops. And how much is the velocity of the truck at that moment? It is 0 because anyway it stopped, so it has no speed. Okay, minus the initial velocity, which is 10 meters per second. Okay, over, which is like 2 seconds. So there you go. We have negative 10 meters per second over 2 seconds. So that is negative 5 meters per square second. That's the acceleration of the truck before it stopped. Anyway, now why there is like negative, why there is like a positive and stuff like that. Okay, using this velocity time versus time graph, we have here from this point at 0 or at rest. Okay, at this point, so let's say this is like point 1, point 2. Okay, from rest and the truck, a certain object traveling at this stop. Look at this. Why is this? In this case, what is the acceleration? Okay, our final velocity is 10 meters per second. Okay, from here to here, when a truck or certain object is traveling like that, our final velocity is 10 meters per second, and our initial velocity is 0 because from rest, right? So acceleration in that stuff we have there. Final velocity, which is 10 meters per second, minus 0 meters per second, where it's not just 0, because anyway it's not moving. And how much the time is covered? It is just 5 seconds. Okay, so there you go. It is 2 meters per second squared. That's the acceleration in this stuff. Now, look at that. It's positive. So acceleration of a certain object traveling a certain speed in a certain time, usually positive from rest to what's this? A certain point. Now, actually, in this case, we call it accelerating. The object is accelerating. Now, in this case, what's the acceleration of the object here? Okay, using this stuff, our initial velocity from here to here, from point 1 to point 2, our initial velocity is equal to what? 10 meters per second. Also, the final velocity is 10 meters per second. 10 meters per second. So we have like 10 meters per second minus 10 meters per second. And how much time is covered at that point from point 1 to point 2? It is from 5 to 15, so it's 10 seconds, right? So there you go. That's 10 minus 10, that's 0. So that's 0 acceleration. Remember, teachers, if the acceleration, if the velocity is not changing, acceleration there is 0. Okay? So there you go. Next one. When can we say that an acceleration is negative? Okay, so as you can from point 2 to point 3. Okay, our initial velocity is 10 and then it stopped, so that's 0 velocity. Okay, and the time covered is from 15 to 20 seconds, so that means it is 5 seconds. Okay, so our final velocity, which is 0 here, and then from here minus 10 meters per second over what's the time covered? That's 5 seconds. So this was negative 10 meters per second over 5 seconds. That is equal to negative 2 meters per second. Always remember, teacher, when an object is traveling at a certain speed and then it suddenly stops, the acceleration there is negative and we call it decelerating or deceleration. Acceleration positive, but actually we just referred everything as acceleration, but when it suddenly stops, the object is decelerating. Or other books, they call it deceleration. Okay? Now, in this case, we're done with the acceleration. Now, we're going to compute how much time, how much distance is being covered by by a certain object if it's in this case. Now, going back with this, we have to compute the area covered by the figure. That is the total distance covered by the object. Okay? So the first one, we have here triangle, and we have another triangle here. Now, look at this. This one is 10, the measure here, and this one is from here and here. This also 10, so this is a square. So the area of this is 10 times 10, that is 100. Anyway, that's 100. And this one, the area here is like, this is a triangle. Triangle is 1/2 base times height. The base is 5 and the height is 10. Base times height, which is 5 times 10, that's 50. Half of that is 25. And another one here, we have, what's this? Base is 5 and then the height is 10 again. So 5 times 10, that is 50. Divided by 2, that is 25. So total, 25 plus 100 plus 25, that is a total of 150 meters. That is the total distance being covered by a certain object, that is the velocity time graph. Okay? So remember those basic information, teachers. Okay, so I'll begin to give discussions more later on. So bye-bye for now.